So how does it really get from this, a rusted hunk of metal, to this, a finished product ready to make a number of products we use daily? As you might imagine, there are many steps to this process.
They come in all rusty and stuff. They just look like they came out of a cast pretty much.
So you've got a lathe operation in which you're turning that down to a precise bar, because it's just a rough piece of steel when it comes in here.
And so we have to turn them down so they're more round, because they come in and they look like eggs. They're not round at all.
And once it's been turned to a particular size, it will go into one of our milling machines. And at that point, what we do is a process called channeling. And essentially what that does is that lays a deep channel all the way down the outside diameter of that bar of steel. So you'll have something that looks like a river channel, or whatever you would want to think in terms of a channel that goes down the entire length of that screw in a spiral fashion.
The screw actually spins the parts you're machining. It turns, your cutter spins, and then it follows a lead, and it makes like a corkscrew style.
And we put hard-facing alloys and fill these channels, and that becomes the top of the flights on the screw. And the reason that you do that is that when this goes into operation in melting plastics, that's a very hostile environment, very abrasive environment. And if you didn't put carbide alloys on the surface of the flights, these things would wear out in a couple of weeks.
It's like, I mean, it's really hard stuff. We can't machine them. Like once it's welded, we have to grind it down because it'll just break cutters.
So what happens at that point is it'll go into the welder, it'll be welded, it then goes into a tank of vermiculite, which will slow cool the screw. At that point, it may stay in there for 2 or 3 days depending on how big the screw is, and the process there needs to slow cool because the weld that is put into the channel has a different rate of cooling than the base steel.
The weld is all uneven, and they have to fit inside of a barrel, which it can only be off like by hairs. So like about 5 hairs on your head. I mean, and we're talking the weld when it comes out of the welder is, you know, it could be off 1/4 of an inch. So we throw them in the OD grinders. OD is for the outer diameter of the screw. And we have certain tolerances that we have to take the OD down to.
Once the hard facing is welded on it, then we actually cut away the steel that becomes the channels of the screw. And that's done on a very, very sophisticated machine, and we are the first people in North America to have purchased a machine that actually is what they call a dual slide machine. It was manufactured in Austria, and it does both the milling function and what they call whirling. You actually have 2 different slides, and you park one slide, and so you're either milling or that you're whirling. And that's how you remove the metal and create the channels in the screw.
At that point, it will come out of the CNC machine. It'll go over to one of our belt polishing stations, which looks like a big belt sander. It'll start at a heavy grit and go down to a finer grit through that process. What we're trying to do is take all the imperfections out of the bar of steel at that point. One of the things that plastics hate is anything that's a rough surface, so that it'll want to stick to and then degrade. So we get a very fine polish on that, on the screw at that point. Probably 95% of our screws are chrome plated, so that's the polishing process that happens right up until the chrome plating. When it comes back from the chrome plater, we will buff it and final polish it. We will also put the drive end on the screw. There are various different milling operations that go into the fit and finish for the actual machine that it will be going into.